So this is the last lesson on logs and exponential functions, and it's how to solve them. And up until this point, we've been dealing with the common log, which is log base 10. So if you noticed, first of all, that's the only one that you can use on your calculator. Also, there is no base shown. So the base is an assumed 10. So when there's no base there, it's an assumed 10. Now, what you're going to do is you're going to start looking at logs in different bases. So if we have log base 5 of 25, so remember a log is just an exponent. So this is saying using base 5, so if you notice it's in subscript, so base, like in the basement, so this is base 5. Log is asking for the exponent on 5 that gives you 25. So again, let me read it again. The exponent on 5, and where do I get exponent? It's because a log is just an exponent. So the exponent on 5 that gives me 25 is 2, because 5 to the second power gives you 25. So again, a log is just a rearrangement of an exponent. The base is here, the total is here, and the exponent is here. So a log is an exponent. Just keep that mantra going on in your head. So now what we're going to do is we're going to be able to solve based on your log properties or log rules. So I'm going to do both the exponential and the log rules, and you're going to see that they really are the same thing. Again, a log is just a rearrangement of an exponent. So I'm going to start with the exponents here. So these are our exponent rules. We already went through these, right? This was earlier when we did our exponent section. So the exponent rules, we had 3 rules. We had the product rule, which states that if you are multiplying 2 exponents, exponential functions, okay, product means multiply, so I'm multiplying 2 exponents. The exponents, as long as my base is the same, all I'm going to do is add my exponents. So the product rule says take your exponents and add them. All right, now if you remember, x to the 5th, so exponential or anything with an exponent, that's repeated multiplication. So you take your base and you multiply it however many times the exponent tells you. So here is my x to the 5th multiplied times my x to the 2nd. So here is my x to the 2nd. Well, what you end up with is repeated multiplication. The base is the same, and I have 1, 2, 3, 4, 5, 6, 7. 7 x's. All right, well, this is just the long way to do this. The product rule tells you when you're multiplying, you add the exponents. Okay, that's the first rule with an exponential. The second rule is called the quotient rule. So with any of these rules, as long as you know the first one, you don't have to memorize anything else because it's already done for you. The first one will lead us to the second. So product and quotient, those are opposites, right? Multiplying and dividing, that's what a quotient is, the answer to a division problem. So this one is when we multiply. This rule is when we divide. So if we added when we multiplied, what's the opposite of adding? Subtracting. So with the quotient rule, if I have x to the 5th divided by x squared, what I'm going to do is I'm going to subtract the exponents. So I get x to the 3rd. Well, if I show you what this means, I have x to the 5th on top divided by x squared on the bottom. What happens is because I'm dividing, the matches or the pairs cancel. So all I have left is x to the 3rd. I have 3 x's left, all multiplication. Again, repeated multiplication. So these two are opposites of each other. When I multiply, I add my exponents. When I divide, I subtract my exponents. Okay, and you're going to subtract top to bottom. So for instance, if you had, let me do it up here, if you had x to the third divided by x to the seventh, we're going to subtract top to bottom, so 3 minus 7, so I end up with x to the negative 4. 3 minus 7 is negative 4. Well, if you were to write it out, which you don't need to because you have the rule, but I wanted to show it to you. So 1, 2, 3, 4, 5, 6, 7, 1, 2, 3. So I have x to the third on top, x to the seventh on the bottom. The pairs cancel. If you notice, I have x to the fourth on the bottom. So when I cancel everything on top, I end up with a 1. X to the fourth on the bottom, well, that's what a negative exponent tells me. Throw it to the bottom. Okay? So, or flip it over. Remember, it means reciprocal. Okay, so those are two of the rules. So let me erase. So again, these are exponent rules. So we had product rule, we have quotient rule, which means we subtract our exponents. And then the third rule is what's called the power rule. Okay, so the power rule, whenever we have an exponent on an exponent, that's what a power is. A power is just another term for an exponent. So if I have x to the third all raised to the fourth power, what we're going to do is we're going to multiply our two exponents. Okay, so here's what this means. X cubed times x cubed times x cubed times x cubed. This is saying I'm using x cubed 4 times. Repeated multiplication. Well, this is the multiplication rule. We can go back to our product rule, which means we add our exponents. So 3 plus 3 plus 3 plus 3 is 12. Okay? So the power rule means you multiply. You multiply the exponents. Okay? So again, as long as you know the product rule, you add the exponents, you can generate the next two rules. You don't have to memorize them. Okay, so those are the exponent rules. So I'm going to erase this, and I wanted to do them both at the same time, so I have room. All right, so I'm going to have to use this down here. Okay, so here's our exponent rules. We're going to keep those because our log rules are exactly the same thing. It's just, again, a log is a rewritten exponent. So we have our log rules. Okay, so the first one is product. So we are multiplying logs. So let me give you an example. If I have log, and we'll use base 10, of 3 times x. What I'm going to do is, because I am multiplying my log, I'm actually going to add. So what I'm doing is I'm expanding this log out. So I end up with log of 3 plus log of x. Now, if I wanted to keep going, I could actually get the answer. Log base 10 of 3, you would just put it in your calculator, log 3, and then we don't know what x is yet. Okay? So product rule with exponents we add. Product rule with logs we also add. So you just split up whatever is inside those parentheses and split it up. So the product rule for logs is you add logs. Okay? Add exponents, add logs. An exponent and a log is the same thing, just rewritten. Okay? Let me give you a couple more just so you can actually see it. If I have log of x times x plus 3, I'm still showing multiplication. When you have something in a parenthesis, that's one term. So I can rewrite this as log of x plus log of x plus 3. Okay, I'm multiplying two logs, which means I am adding the logs. All right, one more. If I had log base 5 of 5 times x minus 1. Okay, I'm showing multiplication. So I have log base 5 of 5 plus log base 5 of x minus 1. Well, Remember, log base 5 of 5. This is saying what's the exponent on 5 that gives me 5? Well, that is 1. So I can simplify this in this format. All right, now, there is no equal sign, which means I can't solve for x yet. All right, the only time you have to solve for x is when there's an equal sign. All right, so this is an example of the product rule. Now let's go to the quotient rule. And I'm going to leave this here. Okay, so the second one is the quotient rule. So this is the quotient rule for logs. Okay, so the example is log of 10 divided by x. Okay, so quotient, with exponents I subtract, so it's the same rule. With logs, I'm also going to subtract. So it's going to look like this. Log of 10 minus log of x. So remember, with the quotient rule, you subtract top to bottom. With the log rule, you subtract top to bottom. So the first one minus the second one. Okay, let me give you another example. This isn't a minus sign. I'm just showing you examples. So log of 3 divided by x is the same as log of 3 minus log of x. Okay, and that's it. No equal sign. I just put that in there so you can see what that looks like. But I'm not solving for x yet. We'll get there. All right, so that's the quotient rule. So I'm going to erase all this. So with the quotient rule, we subtract logs, and now power rule. So I'm hoping you are seeing the similarities. Product rule with exponents, we add. Product rule with logs, we add the logs. Quotient rule with exponents, we subtract. Quotient rule with logs, we subtract the logs. Now we're to the power rule. So it should follow, right? Should follow the same pattern. Power rule with exponents, we multiply the exponents. So let me give you an example. If I have log of x squared, so again, remember, a log is an exponent. So this is showing an exponent on an exponent, just like over here. When we had x cubed to the second power, this is an exponent on an exponent. This is an exponent on an exponent. So what we're going to do, I'm going to do this in red, we're going to drop the exponent to the front, and it's going to be 2 times log of x. All right? So the power rule with exponents says we multiply the exponents. Well, that's exactly what we're doing. We're taking this exponent to the front, and we're multiplying it by the exponent. So exponent times exponent. Let me give you another example. So if I had log of x plus 3 to the third power, I'm going to take this exponent, and I'm going to drop it to the front, and I end up with 3 times log of x plus 3. Okay? Now notice we don't have a rule for adding exponents. Adding exponents. We only have a rule for multiplying the exponents. Okay? Up here, multiplying. So when I drop this to the front, this x plus 3 is in parentheses. It stays together, right? It's one term. All right, let's try one more. Log of x, I'm going to mix it up on you a little bit. I'm going to give you more room. X to the 5th power. I take my 5, I bring it to the front, and I multiply. So the 5 gets peeled off and put to the front, and then I multiply. So those are the rules. Next video, we're going to put all the rules together.